problems. So this is the week 2 of the series of webinars that we are conducting on business analytics as well as digital marketing. In the last week, you might have seen new age digital marketing with business analytics, where we looked at what is digital marketing, what is marketing, and what are some interesting problem statements in marketing that could be solved using business analytics cases. But in this week, we are going to go a bit in detail around the second part, which is that of business analytics, right? We are going to forget about digital marketing just for this webinar. And then we are going to primarily focus on what business analytics is and how business analytics could be leveraged in solving a lot of different problems. So the agenda or the way in which I have actually organized the content is going to be, first we will start with a very basic question, I think, for which you might already be aware of what the answer is. But then we will start with a very basic question, which is that of what is business analytics. Post that, we will actually look at what are the different types of analytics that are available out there and some use cases also. Then the main content of this webinar is going to be, we are going to look at two very interesting problem statements and how business analytics could be applied to these two problem statements. The first problem statement is that of customer segmentation, where we will talk about what is the problem, what are the applications of the problem, what type of data we will be working on, and how we can leverage business analytics to do that. And then the second problem is that of demand forecasting, where again, we will be looking at what is demand forecasting, what are its use cases, and how business analytics could be applied over that. And then finally, I'm going to end this session by giving you some tips as well as some tricks on how to become a business analyst. What are the different things that one is supposed to learn so that we can become a business analyst, right? So have a fun time, guys. I would love to take some questions, but then I cannot take any questions. So it's YouTube live. You can put out your queries in the chat box. Post this is essentially pushed to YouTube. I will try and answer all your questions in the comment section. Right. So let me just get started by introducing myself. I'm not told about me till now. So I'm Kaushik, and I am currently working as a quantitative trader for a financial services firm. I work in the high frequency trading domain, where I write computer algorithms that automatically trades the stock market. I primarily trade the Indian market, Singaporean markets. I traded Indian, Singaporean, and cryptocurrency markets. And then most of my experience has been in the domain of machine learning applied to finance. Earlier, I have worked with investment banks. I have worked with family funds. I have worked with some different funds, mutual funds, and everything. And I'm very fortunate to say that I have been with Guvi right from their day one of the Zen program. I think the Zen data science program started back in 2020. Right from the day one, the first syllabus of data science, data engineering, ML engineering, AI and ML, business analytics, digital marketing, all the course content syllabus has been essentially framed by me. And then I have interacted with more than 2,000 students as part of Guvi. I have personally learned a lot from the students, and I hope that the students have also learned something from me. So that's just a short introduction about myself. Let's not maybe waste any more time. Let's just jump into the main content, right? So as this webinar is completely centered around business analytics, I thought maybe we will get started with the very basic question as to what is business analytics in the first place, right? I think I explained this thing in the last webinar also, and I hope a lot of you might be already aware of what business analytics is. But anyhow, let me just rephrase. Let me just revise quickly what the definitions of business analytics is and what a business analyst does, so that we can deep dive into the rest of the content. Right? So very loosely speaking, any tool or technology that you use to solve a business problem, right, is going to be business analytics. But in the modern day times, this tool and technology, if it is a bit data driven or quantitative driven or statistical driven, that's what we call it as business analytics as such, right, in the modern times. So like 5-10 years back, most of the business analytics tools out there were very qualitative based, right? So let's suppose, right, somebody comes and asks a business analyst as to how much money we should spend on Instagram advertisements, right? Earlier, 10 years back as such, the same person would be answering that question on qualitative judgments, right, based on what their understanding of the market is, based on what they have essentially qualitatively judged. They will just come up with a number like 2 lakhs or 3 lakhs or whatever. But nowadays, this question is more or less answered using quantitative or data-driven strategies only, right? They will collect a lot of data from how much Instagram advertisements we have run, how many clicks they have got, how many views they have got, how many students have joined our course from Instagram. Based on all this data, they try to understand how much money is worth spending so that we have the maximum return on the investment, right? So again, loosely speaking, any tool or technology which is data driven or quantitative driven or statistical driven, which is used to solve a business problem, is going to be loosely defined as business analytics. It just involves a lot of things, right? Very basic tools that you might be already aware of, like mean, median, mode, will also come under business analytics. Or a slightly more sophisticated tool like linear regression, or even more sophisticated tools like decision tree, neural networks, deep learning. Everything, all those tools and technologies can come under business analytics, because any of these tools and technologies can be used to solve a business problem. But very interestingly, guys, I want you to listen to this very carefully. A business analyst will not worry too much about the tool or the technology, but then will only worry about how to interpret the results coming from this tool or the technology. So, for example, that's the primary difference between a business analytics and a business analyst and a data scientist. Right? The data scientist will actually focus a lot on the tool that is used. Right? So, for example, if they are using linear regression, how is linear regression operating? What are the things that are going behind the linear regression algorithm? What does these results mean? All these things a data scientist will be really interested in. Right? If they are using a neural network, what is the math behind the neural network? How to train the neural network? How to control for regularization? All those things a data scientist will be very interested in. But the business analyst will not be interested in that. The business analyst will be primarily interested in how to convert a business problem into a data science problem and solve that problem using these tools, and how to interpret the results of that, the data science models, and give out business insights. Right? So this is like a beautiful story that will connect. If you understand the story itself, you will understand most parts of business analytics, right? So you can just think of like you are working for a data science as a service based firm, right? You are offering data science services to a lot of different companies. Let's suppose a company like State Bank of India comes as a client to you. State Bank of India, when they come to you, need not know a lot of data science, right? The bankers will only know how the banking industry operates. They will only have business problem in mind, business knowledge in mind. So when the State Bank of India comes to you, they will come with a business problem. What do I mean by a business problem? Let's take an example. Just State Bank of India will come to you and complain that their non-performing assets are very high. And then they'll ask you to do some sort of modeling to help them with the non-performing assets. Right? They'll say my NPA is very high. Right? I want you to do something from the data. I want you to find some insights from the data so that I'll be able to control my NPA. Right? This is what the business problem will be. This business problem is not a data science problem. We don't know how to solve it using data, how to convert the problem such that it can be solved using data. We do not know it yet. So the first person who interacts with the customer, right, who interacts with State Bank of India, understands the business problem of State Bank of India and converts the business problem into a data science problem, that person is what the business analyst is actually going to be. So the business analyst will listen to the customer, who's State Bank of India. They will understand the requirements of the customer, and then they will convert the requirements of the customer into data-centric requirements, data science requirements. That's the first thing a business analyst will do. See, to be able to do this itself, the business analyst will require a solid knowledge of business, right? So if the client is from banking industry, then we need to know banking so that we will be able to assist the client. If the client is from the pharma industry, we need to know pharma so that we'll be able to assist the client. So the business analyst in general are very well versed in domain knowledge. Whatever the domain of the customer is going to be, they will be very well versed with that. Okay, so we have converted the business problem into a data science problem. So for example, State Bank of India came to me, told me that the non-performing assets are very high. I have told them, okay, we can control the non-performing assets by carefully choosing the people whom we can give the loan to. So what we are going to do is we are going to build a model which, when a customer comes to me asking for a loan, I will get the details of that customer and put it inside the model. And this model, what it will do is it will tell me whether to give the customer loan or not to give the customer a loan. So what I have done, I have converted the business problem of NPA into a data science problem. All I am telling is a customer will come, will give all the details. This data science model will model everything, and then it will tell whether to give the customer loan or not to give the customer loan. By carefully choosing whom we give the loan to, we will be able to control the NPA. We'll be able to control the defaults that will be essentially going on. So that's what the first thing a business analyst will do, which is convert the business problem into a data science problem. Okay, good. To solve a data science problem, what do we need? To solve a data science problem, though, we need data. So that's what the second thing that the business analyst will do. For sure, like usually the business analyst will take the help of the data engineer or they will take the help of some other people to do it, which is they will collect the data. Right? Because State Bank of India will not store all the data in one place. They will be storing different pieces of information in different databases. So we will need a person who will essentially fetch the data from all the places, stitch it together and readily give the data. That's what collection of data is going to be. Again, as I said, the business analyst will not do the collection of the data. There will be some specific data engineers who will be responsible for that. But still, right, sometimes they will take the help of someone else or they might have to do it themselves. So the first thing is we have converted the business problem into a data science problem. The second thing is we have collected the data that is required to solve that problem. The third thing is going to be the business analyst will take the help of tools or technologies or data scientists to solve that problem. What do I mean by that? See, again, as I told, business analyst does not require a lot of coding knowledge or math behind the model knowledge. They don't care about that. They will have some ready software like Tableau, Power BI, which will do all those things for them and will give the final answer. So they'll either take the help of the data scientist or they will take the help of these softwares like Tableau, Power BI to solve the data science problem and give out the solution. Right? Once they get the solution, this is where a crucial step happens, which is the business analyst will apply their domain knowledge to interpret the results and convert the results into future actions. Right? So they will essentially be leveraging, like they will be using all their domain knowledge that they have to essentially say, okay, the model is telling numbers like 0.3, 0.4, 0.5. This means that you need to do these things. Say they'll come up with the final insights. They'll come to State Bank of India and say, don't give loan to people who have not graduated. I'm just giving an example. It's not the case. And don't give loan to people who have a credit score of less than X level. Like that, they will essentially finally communicate their key insights and advise future actions. Again, just repeating, first step is the customer will only know business. So as a business analyst, we need to talk to them, understand the business lingo, convert their business problem into a data science problem. Post that is done, we will be collecting all the required data using the help of few data engineers. And then we'll be using few tools and softwares like Tableau, Power BI, or we will be using for data scientists to solve the data science problem. And finally, after solving the data science problem, we will try and understand or interpret the model to understand key insights. And based on the key insights, we will give future actions as such. This is what a business analyst will usually do. And from whatever I have explained itself, one thing will be very clear to you guys, which is that a business analyst requires very, very good domain knowledge. They require solid business knowledge. And post that, they don't require a lot of coding skills, but then they need some coding skills as such, right? Not a lot. All they need to do is just learn how to operate these low code platforms like Tableau, Power BI and all is just going to be like a UI. Just like how you do things in Excel, you can essentially be able to do that in Tableau, Power BI also. So they need to know that basic amount of that coding, right? Not coding, just using these softwares. And they require very good domain knowledge. They require decent knowledge of machine learning and very low knowledge of programming or coding in the first place as such. So yeah, I have spent a lot of time in explaining what business analytics is essentially going to be. Just making a gist, business analytics is a set of tools or technologies that you use to solve a business problem. The only catch is that these tools and technologies are all data driven, statistical driven, and quantitative driven. right? And the life of a business analyst is going to be, this is a person who has a very solid understanding of business knowledge, domain knowledge is very good, medium understanding of data science skills, and then very low understanding of coding, because they usually are not the ones who code. They usually use these low or no code platforms like Tableau, Power BI, Excel, and stuff like that only, right? So we have just looked at what the story of how a problem gets solved, right, in the business analytics domain. I have given a lot of examples like customer segmentation, demand forecasting, and all, but we will come to that a bit later, because the second part of the webinar is all going to be about taking these two problems and explaining that in detail only, right? The next thing that we are going to look at is, what are all the different types of analytics that is available out there in the internet, like out there in the world, right? So this is a very interesting thing, right? When I explain what the types of analytics is going to be, I'm just going to tell you what are all the different things that people are looking at when they say analytics as such, right? And how this field has evolved, and how the evolution of the field is going to have a big impact on what you need to learn, right? We will come to that bit. To actually understand these types of analytics, let's take an example, right? Let's take one of my favorite examples, which is that of corona itself, right? How the COVID virus was essentially detected, and all what were all the other things that happened after that, right? So let's, maybe I'll tell you a flashback kind of story. Let's just rewind our clocks back to the 31st December of 2019, right? Just put yourself in 31st December of 2019, but you are not in India, but you are in a place called Wuhan, which is a city located in China, right? So put yourself in that situation. What was happening was, the government offices in Wuhan, right, on 31st of December 2019, and the dashboards that they have built on those software, they were all showing some sort of warning. On 31st December 2019 in Wuhan city in China, all the Chinese monitoring applications was essentially showing some sort of warning signs, which was saying that something wrong is happening. All the hospitals in the city of Wuhan are getting full. That's what the warning was essentially about, right? The warning was essentially about, all the hospitals in the city of Wuhan are all getting full, and it was just throwing some warning. This type of warning or analytics in business analytics lingo is what is called as a descriptive analytics, where what we are talking about is, we are talking about what is happening or what happened, right? Over here, these dashboards are just showing you, just warning you that the hospitals in the city of Wuhan are getting full, right? There's just an event that has happened, and these analytics dashboards are essentially just showing you that these hospitals are getting full, and then just warning you as such, right? This is what is called as a descriptive analytics, and this primarily talks about what has happened. Over here, the event that has happened is that the city of Wuhan's hospitals are getting full. Post the government officials saw this warning, they sprung into action. They wanted to understand, why was this happening, why was the hospitals in Wuhan getting full. So they start essentially investigating into it. They start making their phone calls on different hospitals. They start getting some data, and then they figure out that two things, right? All the people who are actually coming to the hospital all have like cold or fever like symptoms. Cold, cough, fever sort of symptoms is what they have. Right? So this is what is called as a diagnostic analytics, which is, after an event has happened, we would like to understand why it happened. So the event has already happened, right? That the city of Wuhan, the hospitals have got full. That's what the event was. Now we need to understand, why is it happening. That's what is called as a diagnostic analytics, right? And this is happening because everybody is coming complaining on the signs of fever. So what these government officials essentially do is, they take some lab tests essentially, and then they send it out to testing laboratories to understand what is causing this sickness, right? And then they figure out that this is a new strain of virus which is actually causing this problem, and then they name this virus called COVID. Again, guys, listen to the story very carefully. The dashboards in Wuhan city of China was just showing warnings saying that the hospitals are getting full in the city of Wuhan. Right? This is what is called as descriptive analytics. What has happened? It just says what is happening or what has happened. Then the government officials sprung into action, and then they figure out two things, which is all the people coming there are admitting are coming from fever symptoms. So they do essentially send out the test results to laboratory, and the laboratory is confirming that they are all infected by a new virus, and then they call this virus called COVID. Now this becomes a serious issue, right? Okay, people are getting sick and they are coming to the hospital. What if this continues? What will happen next? That's what is essentially called as a predictive analytics, right? Where if this situation continues, what is going to happen? How many people will get infected? How many people will require medical treatment? How many people will die because of it? Right? So if you remember in 2020 and all, right, if you have read the newspapers, all those newspapers would be just filled with these charts only, right, where they will just show the charts of how many how cases of COVID are there, and then they will predict if this pattern continues, then how many will get in hospitalized within next 5 days, 10 days and all, right? So that's what they essentially tried to do, but this time they tried to get the help of epidemiologists to build models to predict what will happen next. So that's why the exponential models and all were built, and then the epidemiologists said that okay, if this situation continues, then like 20% of the population would get sick, and then the hospitals would overflow by 10 times, right? Like that they essentially make some predictions. This is what is called as predictive analytics, where we are trying to predict what will happen next. In descriptive analytics, we are just trying to understand what has happened. In diagnostic, we are essentially trying to find out why did it happen. And in predictive analytics, we are trying to figure out if the situation continues, what will happen next. So the epidemiologists essentially paint a very stark picture, right? The picture is that if this continues, everything will be bad. People will get very sick and a lot of people will die. Hospitals will overflow. They essentially paints this picture. And the final thing is, hearing all these, the main government officials as such, right, the people who are administering the country need to take a call. They need to put an end to it. They need to stop the spread of the virus, because if this continues, a lot of people will die. Hospitals will overflow. To stop it, what is the best way to stop it? They try to understand that, right? I want to stop it, but I don't know how to stop it. I don't know what is the best way to stop it. Essentially, to find out what the best way to stop it is what is called as a prescriptive analytics. That is, we know what has happened, we know why it has happened, we know what will happen next also. But then if we want to alter the path of what is going to happen next, if we want to stop it from happening or we want to accelerate it from happening, in both the cases, how will we make it happen? That is what is called as prescriptive analytics, right? You want something to happen and you want to find out how to make it happen, and that's what prescriptive analytics is actually going to be about. Again, in the story, the Wuhan dashboards are essentially showing that the hospitals are getting full, which is called as descriptive analytics. Post that, we try to find out why it is happening, and then we find out that it is happening because of a new virus called COVID. That's called diagnostic analytics. Then we try to predict what is going to happen next, which is called as predictive analytics. And finally, we want to stop it from happening. How do I go about doing that? In that case, though, in China, the answer that they came up with was lockdown. They said we will essentially force everybody to stay at home so that we can break the spread of the virus, and it worked very effectively. And that's what is going to be called as a prescriptive analytics as such. And in general, as you can see from this graph itself, the complexity is going to be the easiest of things to do is descriptive analytics. To find out what has happened is the easiest. Why did it happen? To figure it out is also relatively easier. Then a bit difficult is going to be predictive, and the most difficult is essentially going to be prescriptive. And higher the difficulty, more the value that it will add. By just knowing what has happened, we are not going to gain a lot of value. But by knowing why it has happened, we might get some more clarity. By predicting what is going to happen next, we have a lot more clarity. We will be able to take better decisions based on that. It's a very high value problem. And by understanding how to make certain things happen the way we want, we'll be unlocking the highest amount of value from the problem statement as such, which is what the prescriptive analytics is going to be. And so guys, in the business analytics domain, primarily, right, if you had looked at it in the last 5 to 10 years, or maybe 10 years back or 5 years back, Most of the things that people were doing was descriptive diagnostic, and here and there they will essentially do some predictive sort of analytics, right? But now the industry has primarily shifted or tilted into the higher side, right? The descriptive and diagnostics are all more or less automated to figure it out, right? Now the most of the money or most of research and most of the value is essentially getting unlocked only in predictive and prescriptive analytics. And to be able to do that, it's a very highly complicated problem, right? We need to get equipped properly in business analytics, and that's what this webinar is essentially going to talk about: how to get properly acquainted through business analytics, how to get a proper learning of business analytics is what this session is essentially going to be about. Right, so I've just spoken for a long time. Let me just quickly revise. The first thing that we talked about is what is business analytics, and we looked at what the how when a client essentially comes with a problem statement, what are all the different things a business analyst will do to solve that problem statement. Then the second thing that we have looked at is what are the different types of analytics that are out there, and what sort of value could be unlocked in each type of analytics as such. Right, so these are the two things that we have primarily spent our time on learning. Right, next what we are going to look at is, okay, we have got an understanding of what business analytics is. We have got an understanding of what are the different types of analytics that are out there also. Can we now look at some applications? Because as I had mentioned in the beginning of the session itself, this session is primarily concentrated on how business analytics could be applied to real world. And in real world, though, we are primarily looking at two problems. One is customer segmentation, and another is going to be demand forecasting. So we are going to zone in like on the customer segmentation problem statement as such, right? So customer segmentation is actually pretty easy problem statement, right? Let's suppose you are running any business. You have a lots of customers as such, right? You want to find out which all customers are all similar to each other. You want to group your customers into different parts based on a set of features, so that you can give targeted advertisement to each group. You can give specific discounts to each group. You can essentially cater or make products catering to different consumer group as such. Right, so that's what customer segmentation is about. You have a set of customers for whom you have a lot of data on. Right, you have collected lots of data on the customer, how much transaction they have done, how what are the what are the behavioral patterns like, and everything. Based on all that data, you would like to divide your customer base into groups so that you can actually give targeted discounts, advertisements, and everything to each group as such over here. This is what the problem of customer segmentation is going to be. Okay, by doing that, what will my benefit? By dividing my customer into different parts, what will be my benefit? Once you essentially do it, as I had said before, we can give targeted advertisements, we can give different prices, we can give product recommendations. Right? If you have noticed something, if you go to Amazon.com and I go to Amazon.com, the web page that Amazon will show us will be different. In your web page, let's suppose they might show you data science related books. In my homepage, they might show me, sporting goods or something like that. How does Amazon essentially know what to recommend to what person? By using customer segmentation only. What Amazon simply does is they try to find out which all customers are similar to each other. Let's suppose there are two customers, one called John and another called Abraham, right? And if they find out that John and Abraham are very similar to each other, John and Abraham have the same taste, then what they will do is they will essentially put John and Abraham in the same group. Once they put John and Abraham in the same group, whenever John purchases some goods, that goods will be recommended to Abraham, and whenever Abraham essentially purchases a good, that good will be recommended to John also. And this is how majority of the product recommendations essentially work. They divide the customers into different groups, and after grouping them from each group, right, whatever one purchases, it will be recommended to the rest of the members of the group also. So that's what the statement is essentially going to be. Like, that's what the application of this problem statement is going to be. And who uses these things? Everybody does it, right? Any person who is doing product recommendation, right, is actually using customer segmentation as such, right? And like if you open your app, any app in your phone, majority of the firms out there are doing product recommendations. How so? If you go to Spotify is recommending music to you. So music recommendation they are doing. How? By doing customer segmentation. Right? If you go to Netflix or Disney Plus Hotstar or Amazon Prime, they are recommending movies and TV series to you, again using customer segmentation. If you go to Amazon or Flipkart, like e-commerce platforms, they are recommending products and goods that you can purchase, again using like customer segmentation. If you go to Swiggy or Zomato or anything, right, or Zepto or Blinkit, they are recommending food to you, they are recommending products to you. How? Again using customer segmentation. Right? Even if you go to a matrimony website, right? They are recommending brides or grooms to you. How is that working? Again, through customer segmentation only as such, right? So any application out there, if you, there's the same thing with respect to Instagram is recommending reels to you, YouTube is recommending shorts and videos to you, right? Twitter is essentially recommending tweets to you, right? Reddit is essentially recommending threads to you. So all the applications out there does some sort of product recommendations to keep their users engaged, and all these product recommendations are primarily built on top of the customer segmentation problem only, right? Once again, dividing the customer base into different groups is what customer segmentation is about. Post we divide them into different groups, we will be able to give product recommendations, targeted advertisements, pricing, discounts, and everything to each group, right? And everybody out there, right, more or less everyone out there is essentially doing it. If you take an airline also, airlines also do customer segmentation. They try to find out who are all the customers who fly short distances and who are all the customers who are flying long distances, and then they try to offer some free services catering to each of these customers base as such, right? This is what the problem of customer segmentation is. It's a $1 billion problem, right? Any firm which is deploying some amount of data science will for sure run customer segmentation algorithms, right? Now what we are going to do is we are just going to look at a bit deeply into what customer segmentation is essentially about, right? So what are the use cases, right? Talking a little bit about use cases. We have already looked at pricing and discounts. Once I find the different groups, I'll be able to give special discounts to each group. That's what Swiggy does, right? If you are paying a lot through UPI, then what Swiggy will do is they will essentially give you a lot of discounts for, paying through UPI. If there is a person who is essentially paying a lot through Sodexo card or something, then they will get some special discounts for that, right? So pricing and discounts is a classic example. After you divide the customers, that's one use case. Another is up or cross selling, which is you are already selling some product. For example, Amazon, right? Amazon has like millions of customers, right? They will divide the customer into who are all like more likely to join the Prime program and who are less likely to join the Prime program, and then they will try to upsell, right? Rather than just using the vanilla Amazon, they will try to ask you and like enroll yourself for the Amazon Prime, right? So that it will be better for you. The same thing with respect to targeted advertisements, right? Each group will be shown their own advertisements, right? And then finally it's going to be product recommendations. We have talked all about it in detail, but these are some classic use cases of where we can deploy customer segmentation. And as I said before, every firm out there who's using any sort of data science to derive value is more or less doing customer segmentation to understand their customers better and to offer all these use cases as such, right? So we have seen what customer segmentation is, and we have explained in detail what the use case of the customer segmentation is going to be. Next, what we are going to do is we are going to talk a bit about the data part of customer segmentation. What type of data is collected or used in running these customer segmentation models? So as I had mentioned before, the problem statement is to divide the customers. But what will we divide it based on? We can primarily divide the customers based on 4 types of data. The first is the based on their transaction. So let's suppose you are Amazon, right? You have a particular customer. You have what are all the different transactions that the customer has essentially done in your platform, right? You will know what their average transaction value is. You will know what their total transaction value is like. You will know what the total number of transactions that they have done is going to be. You will know what their preferred payment type is essentially going to be. All these are transaction related data, right? That a customer would be very like, you will have on them. The second is going to be behavioral type of data on the customer, right? What is the favorite category of product for that customer? What is their favorite brand? What is their favorite color? What do they search a lot? What type of product do they search a lot? Do they essentially search makeup products? Even within makeup products, what sort of brands do they search, right? What sort of goods do they search? All this is what is going to be behavioral data, where we try to collect some data on the behavior of the customer. How many times do they log into Amazon? How many times they search in Amazon? Before purchasing a product, how many times will they look at it, right? All these are going to be behavior related information. The third is going to be demographic related data, right? Which is what is the age of the person, gender of the person, what is going to be the marital status, what is their location, right? All these are going to be data that we'll get using the IP addresses or from their saved addresses and stuff, and we'll collect some demographic data on the customer. And finally, we will collect some information about their loyalty, right? How often do they use Amazon, right? How often are they likely to, how likely are they to take up a new product, right? How likely are they to essentially subscribe to a premium service? What is their frequency of shopping? These are all going to be some loyalty related data points as such over here, right? So primarily we have transaction data, which is based on what are the sort of transactions they do. Then we have the behavioral data, which essentially talks about their favorite category of product, favorite color and everything. Then we have the demographic data, which is essentially talking about their age, gender, location and everything. And then finally the loyalty, how loyal are they using, what is their frequency of shopping, what is their, whether are they subscribing to premium services, are they going for up sold products or cross sold products, right? That's what the loyalty information is going to be. Now, what we are going to try and do is using business analytics tools, we are actually going to collect these customer segmentation data and we are going to look at how business analytics tools can help us give segments of customers. So on each person, we have collected all this data. So we just have a massive amount of data, right? So we need to just find a model or any business analytic tool that we will be able to use so that we can just plug this data and then get different customer segments of the customers, which we can use further. So this is what is actually called, right, in machine learning lingo, this is what is called as a clustering problem, right? This is what is called as a clustering problem. And for clustering, we have this very important model or very famous model, which is called as k-means clustering, right? So as part of model building, what we will essentially do is we will just collect all the required data, we will do some cleaning of the data, right? Because any data that you will actually collect will have a lot of problems, right? It will have like missing values, it will have outliers, it will have data that makes no sense, right? Like the data will go haywire here and there. We need to identify all those places and we need to essentially thoroughly clean the data such over there. So the third step is going to be, post we clean the data, then we will do what is called as a exploratory data analysis, which is we have the raw data which we have cleaned, which is looking tidy and everything. Now we need to try and visualize this data, we need to try and explore the data so that we can get some basic insights out of them. That's what is going to be called as exploratory data analysis, right? Where we are trying to explore the data, where we are trying to visualize the data to understand it better. And the fifth thing that we will try is we will just build the model, right? These parts are all more or less fully automated as such. If you go to Tableau, you just export that, import the data, whatever data that you want, you just hit a few buttons and then like the k-means clustering algorithm will be run and the final results will be displayed to you as such. Right? That's how abstracted out these models are. Right? You don't need to know anything about how the model works or how to interpret it and stuff. Right? Interpretation though we obviously need, we will come to that. But then how does it work and all we need not care about. Everything will be taken care automatically by a tool. And then finally the tool will tell, okay, these customers are all similar to each other. Those customers are all similar to each other. Like that, it will just give you the groups as such over here. Right? We first defined the problem, collected the data, thoroughly cleaned the data, and then we explored the data. That is, we visualized the data and understood, and then we actually built some models around it. Right? Primarily, we built this model called k-means clustering, which is a clustering algorithm. And then after clustering, we will get the interpretations of the model. And the interpretations are again a very important thing. Right? So as a business analyst, what you will do is you will try to interpret what do you mean. Why does it say that these all customers are belonging to one group? What is the main property of that group? So once the k-means clustering algorithm tells you, okay, these customers form a group. Now next what we will do is we will try to understand what is the average property in each group. Right? So when we do that only, we will get to know, okay, the k-means clustering algorithm is dividing the customers based on the favorite color. Right? These customers have the favorite color as blue, while the other customers has favorite color as white. Or these customers essentially pay do high value transactions and usually pay via credit cards, while the other group of customers do high value transactions but pay using cash on delivery, while other customers essentially do low delivery but then cash on delivery, low transactions but then cash on delivery. Like this, we are required to interpret the model, because the model will only throw out numbers to you. Right? The model will only tell these people are all similar. It's our duty to find out why is the model saying that. Right? How do we go about interpreting the model? That's what the sixth step that a business analyst will try and do. Right? I've just spoken for a long time. Let me just summarize this customer segmentation part alone. We have lots of customers and we have lots of data on each of the customer. us trying to group our customers into different groups or bins is what customer segmentation is going to be about. And customer segmentation has a lot of use cases. Like these final groups can be used for targeted advertisements, product recommendations, upper cross selling, and many more, right? And then everybody is essentially using it, right? Any company that's doing product recommendation is essentially using it. Any company that is essentially doing data science is actually going to deploy these customer segmentation models. And finally, to solve the customer segmentation model, we just divide it into 6 parts. One is that of problem statement definition. We'll collect some data, we'll clean the data, then we will visualize the data to understand it better, and then we will build the clustering algorithm, and then finally interpret the clustering algorithm. Right? So this is what customer segmentation is actually going to be about. Right? The same way, the second problem that we are actually going to look at is that of demand forecasting as such over here. Right? Demand forecasting is also a very, very interesting problem in the first place, guys. Right? So any company, right, be it any company as such, be it an FMCG company or an automobile firm, or be it TCS, CTS also, right? The most important thing that these companies need to plan is how much demand is present for their product. So for example, let's suppose you are Britannia, right? You are the responsible for manufacturing Milk Bikkies biscuit, right? Now the question is, how much should I manufacture? Should I manufacture 1 lakh packets of biscuits, or should I manufacture 1 crore packets of biscuits, or should I manufacture 10 crores? We need to give a definitive answer to that, right? If we manufacture a lot of packets and only a few of them get sold, then there is just a massive loss, right? Let's suppose we manufacture 100 while only say 80 get sold, 20 packets are wasted. So all the money that we spent in manufacturing the packets will go to waste. But in the opposite case, if you sell 100, sorry, if you manufacture 100, but then there was demand for 110, then what you have lost is an opportunity cost, right? You had an opportunity to sell to 10 extra people. The God gave you the opportunity to sell to 10 extra people and make more profit, but then you did not do it, right? And it will also be a reputational damage, right? Because very simply, this has happened to me also, right? I would go to a store asking for a particular biscuit packet. The biscuit packet is not there, and if it happens for 2 or 3 times, then what I'll think is, oh, that biscuit packet will never be there, and then I'll switch my taste to some other biscuit packet company, right? So there will be reputational damage. If the demand is high and the supply is low, then there will be an opportunity cost lost, and then there will be reputational damage. While in the opposite case, there will just be a wastage, a lot of wastage, right? So any company, right? This is the case for say automobiles also, right? Let's suppose you manufacture 100 particular car, like say Tesla S model or something, and then only 80 of them got sold. Then what will happen? The 20 cars will go to waste. Every money that you spent on building that car will go to waste. So a company would try and avoid it as best as possible. And how can we avoid it? We can only be able to avoid it if we can forecast our demand correctly. If I have some magic wand, like sort of thing, which will forecast the demand for the next quarter to me and correctly, accurately tell me, if I have a wand like that, that will be very useful. Right? Using that, I will be able to demand, like, forecast my demand more accurately. And based on that forecasted demand, I'll be able to, manufacture goods also, so that I can reduce wastage. Right? So that's what this demand forecasting is essentially about. It is about the technique for the estimation of a probable demand for a product or service in the future. In the future, I am selling some products or service. I want to find out what sort of demand is there for that product. Right? That's what this problem statement is about. And as I had said very clearly, right, there is so many applications. Any company which is offering any product or services will do demand forecasting. Even TCS, CTS are doing it, right? Because they need to plan work, right? So how they'll predict how much project will come the next quarter, how many resources should we allocate, should we hire more people, or should we fire existing people? Like that, they will essentially decide based on the demand forecast that they are building only. And demand forecasts are used everywhere, from manufacturing, FMCG, IT, to any BFSI. Everywhere where we are selling a product or a service, the demand forecasting models will essentially be running. Okay, good. What are the use cases for demand forecasting? Right, number one, very simply, inventory management. Right, how many goods should I keep ready? Right, so that I don't waste. Right, how inventory management is going to be about how much should I keep ready? How much demand should I essentially have? How much demand will I have? So that I can plan how much I should keep ready. And the second thing is, you will be able to use it for earnings forecast. right? So every time, like especially public listed companies, say Reliance and all, in annual general meeting, they will tell you, okay, in the next quarter, we are expected to earn this much amount of money. How do they know that? They are just predicting the demand, and based on the predicted demand, they are essentially coming with a value over there, right? And then this demand forecasting will also give you answer to whether there is any opportunity for expansion. Let's suppose you have only capacity to build 100 packets of biscuits, but then there is a demand of like 200 or 300. Then you can expand your operations, right? You can collect more money, build more plants, right? Build more manufacture, build hire more people, and then expand your business as such, right? So the opportunities for expansion will also be gauged by demand forecasting models. And finally, you can use these models to understand what effect your competitors are having on you also, right? For understanding competitive advantage, to essentially understand reasons for expansion, to give earnings forecast, and also to do inventory management, demand forecasting becomes a crucial tool. Hey guys, both the problem statement, right, be it customer segmentation or be it demand forecasting, these are two very very important problem statements in any field, right? Whenever you are running a business or a service, these are two things that you will be deeply interested about, especially as your business grows and grows. You want to understand it much better so that you will be able to chase more growth, right? So that's what the application for demand forecasting is going to be. And if we look at what are all the different approaches that are there in demand forecasting as such, the first approach is essentially going to be based on the historical sales data, right? Based on whatever, how much ever quantities I have sold in the past, just building models on top of that, right? Is what historical sales data is. That is one way or one approach to demand forecasting, just based on your data. That is, in the last quarter, I had sold 100 packets. So based on just that information, based on more information on the historical data, we'll be able to find out what the demand will be. Or second is macroeconomic indicators. We look at our historical sales. On top of that, we will also get as to how the economy is behaving, because more the better the economy, higher the chances of my demand rising up, right? Lower the inflation, higher the chances of essentially expansion or such over here. So these macroeconomic indicators will also be used as one sort of data, right? Using which you'll be able to predict the demand. And then you have promotional activities, right? So let's suppose, see, whenever you run any advertisements, then the demand will shoot up, right? Whenever you run these promotional activities, the demand will essentially shoot up, right? So to understand, to take that into effect also, we will bring in the data on how much money we spent on advertisements, how much promotions we have done in the last quarter, and we can use that information to predict what the demand will be for the next quarter. So this is all used in general in tandem, right? All of them are used together, right? Whenever a company is making a demand forecasting model, they will bank on their historical data, they will bank on macroeconomic indicators, they will bank on how much promotions and advertisements they are running, and how much competition is there in the market. Using all this data only, the demand forecasting exercise is essentially carried, right? More and more the data that we collect, and then we plug it into the model, right? Better the models will be, better our demand forecast will also be essentially. Okay, so these are the different approaches and what are all the different types of data that we have on the demand forecasting side. Right? And then there are lots of types of models also. We will not talk in detail about the models. There are some causality models, there are some time series based approaches, then there are some qualitative approaches also on demand forecasting as such. Right? Again, guys, let me just repeat once more. Demand forecasting is essentially about predicting how much demand will be there for my product or services that I'm offering. Any company which is offering any product or service will be interested in it. There are lots of use cases like inventory management, understanding the competition, understanding whether there is scope for expansion, right? All these are some applications. And then with respect to the data can range anywhere from your historical sales data to macroeconomic indicators to what sort of promotional activities you are running, and finally the sort of competition that you are having also, right? So, just summarizing, right, on whatever we have talked till now, first we looked at what is business analytics, right? And then we saw that any tool or technology that we use to solve a business problem, but this tool and technology is more data driven, quantitative driven, statistical driven, is what a business analyst tool is going to be. And then we saw this story on how a business analyst will solve the problems for a customer, right from the time that they get onboarded till the time they leave. Then we looked at what are the different types of analytics out there, and how predictive and prescriptive is where most of the value and complexity essentially lies, right? And then we started looking at the examples as such over here, where we first started out with the customer segmentation problem statement, right? We understood what the problem statement is, what the data set is essentially given, and how we can go about approaching it. And then second, we have looked at what is demand forecasting, what are the applications of demand forecasting, and what are the different types of data that we can use. The methodology is going to be the same, right? Just like how I told you in customer segmentation, first we will collect the data, we will thoroughly clean the data, we will explore the data, we will build the models using these tools and technology software, and then we will finally interpret the models. The same thing that we do for demand forecasting also such over here, right? So towards the last part of the webinar, I would like to primarily spend on what type of skill set one should actually develop so that they can become a business analyst, right? We have looked at what is business analytics, we have looked at what are different types of analytics, we have looked at a concrete couple of examples of business analytics also. Now I'm going to tell you about what sort of skill set. Now the question is, how do I become a business analyst? What are the different things that I need to learn? That's what we are going to see next. Primarily for a business analyst, there should be three types of skills they should have. First, they should have basic computer science skills, right? They should be able to comfortably use things like Excel, SQL, and stuff like that, right? Not a lot of programming, very, very basic things only, right? Excel and all is purely UI driven. And how do you use about Excel? How do you use about SQL and all? You are required to know first. Then you are required to know all these tools that are used for business, like modeling and any sort of analytics and dashboarding, like Tableau, Power BI. These are classic examples, right, of certain software that is used a lot, right, to run machine learning models, to essentially make dashboards and everything. And finally, very importantly, you need to have a lots and lots of business knowledge, because as I had said before, business analyst primarily thrives on their domain knowledge only. So you should have a very good knowledge of what the industry is, how the industry operates, what are the pain points, what are the compliance points, everything you are required to know about the industry for which you are working as a business analyst as such. Right? So to become a business analyst, three important skills: basic computer science skills, basic tooling skills, especially on Tableau and Power BI, and third, very solid, rock solid domain knowledge. Right? These are the three important things that we might require. Right? So finally, I would actually like to end this session, right, based on by giving you a career path on how to exactly get hired as a business analyst, right? So as I had said before, first to learn basic things like Excel and SQL. These are called as database management tools, right? Again, there are low and no code versions of the same thing. First, we are required to learn those very basic data handling tools. Then we need to essentially learn a very good amount of business knowledge, right? The business terminologies, the requirements, what are all the KPIs that are essentially being tracked in different industry, right? What are the compliance essentially like? What are the customer rules essentially like? Who are the customers? Right? A lot of questions around the business side is what next one is required to actually get equipped themselves on. The third thing is, once this is done, we need to essentially focus a lot on Tableau and Power BI, on using or learning these tools called Tableau and Power BI. Right? And finally, once we know that, then we can learn a bit of machine learning and modeling, especially, right, more than the model itself, will be learning how to interpret the model, how to understand the model correctly. So that's what the last step is essentially going to be. First is database tools and computer science skills. Second is going to be business terminologies and requirements. The third is the visualization and communication tools like Power BI, Tableau. And finally, we will learn a bit of modeling and machine learning so that we'll be able to apply all this knowledge. Okay, good. We are towards the end of the session. Let me maybe summarize the entire session in one go, and then I'll stop over here. So first we started out with what is business analytics, types of analytics. Then we tried and understand two important problem statements, one on customer segmentation and demand forecasting. We understood the problem statement, the application of the problem statement, and what type of data would be given and how we can go about modeling the data. And finally, we looked at the sort of skill sets a business analyst must have. And if you wish to become one, how do we go there, right? The career path for the same is also explained over here, right? Again, guys, if you would like to actually get started on a career in business analytics, I feel this is the best time. The industry is growing massively. There are lots of certifications or courses out there that you can actually use and try and learn. You can also look at our Guvi page, where you will be able to find the curriculum and syllabus and go to style for the business analytics course. Okay, so do give it a try. And I would love to take some questions, but I'll not be able to do in this stream. So whatever your questions are, you can put it out in the chat box. When I see the video in YouTube, I will try and answer all your queries as such, right? I wish you guys best of luck. I'm very happy for watching the second part of the series. And last week was business analytics with digital marketing, and this week was some real world applications of business analytics. Right? I'll see you guys in the next week with some other very interesting problem statement. See you guys. Bye bye. Thank you. Yeah. Niveda, over to you.